Welcome to Circuit Adda, and today we are going to have another video from Arduino series. Here we are going to interface an LED with an Arduino board. So let us start the video. So here you need an Arduino board and an LED. You can take any color of LED. It may be red, white, green or blue, whatever the color may be. We are just going to make LED blink and we are connecting the LED to the board. So let us see how we are doing all these things. First of all, we have to open our Arduino IDE software. After opening the Arduino IDE software, if you click on the file menu and then if you click on the new menu, then you will get a new tab like this. This is the new sketch file where you can write your new Arduino code. So here you can see clearly there are two types of paths. The first one is the void setup and the second one will the void loop. These two are very much important for programming the Arduino. First of all, you have to understand what is void setup and what is void loop. So whenever we come into the void setup, whatever code you will write in the void setup loop, you can see the loop here, the loop starting from this flower bracket to this flower bracket. Whatever code you write in this particular loop, whatever you write in this flower brackets, the code will run only for once. That means whenever you switch on your Arduino, whatever the code you write under void setup, it will get run only for one time whenever the Arduino get powered. And after that, the code will run continuously in the void loop. That means the void setup, whatever you write in the void setup, it will run for one, and whatever you write in the void loop, it will run multiple times until and unless your Arduino gets shut down. So you have to understand these two basic things, and then let us move into our Arduino. Let us move into how to interface an LED with the Arduino board. So, I think most of the people who are watching this video don't have the Arduino board with you people. So there is no need to worry that you don't have the Arduino board. How can you run a program? How can you interface an Arduino or LED with an Arduino board? There is another easy way for interfacing LED to the Arduino board without having any Arduino board, which is known as virtual Arduino simulation. So here we are going to use some virtual tools where we will get an Arduino board, we will get a LED, and we are going to interface the LED with the Arduino board virtually. And we are going to write the program and we are going to make the program run. So for that, you have to go into the website known as ThinkerCAD.com. This is the website. We have to open your browser, and you must have an internet connection. You must have to go into a website known as ThinkerCAD.com. I am also going to give this particular website under my description. So in the ThinkerCAD, it is a virtual Arduino simulation platform designed by the Autodesk company. So after opening this website, you have to sign in. If you are new for this website, you have to join. You have to create an account in the ThinkerCAD by clicking on the join now button. As I already have an account, I am going to sign in the ThinkerCAD. After getting signed in the ThinkerCAD website, you will get the dashboard of the ThinkerCAD. In the dashboard on the leftmost side, you can see here there is a tab known as circuits. You have to click on the circuits, and after clicking on the circuits, here you will get an option create new. Whenever you are going to open the ThinkerCAD for the first time, just click on the create new circuit, and after clicking on the create new circuit, you will get an space where you can add your Arduino board, your LED and the breadboard, and you can connect all the LEDs onto the Arduino through the breadboard, right? So that this is the window which is going to be open whenever you click on the create new. After clicking on the create new, here on the rightmost side you will see a search bar. Click on the search bar and type Arduino. After clicking on the Arduino, you will get the Arduino board here. As we are using an Arduino Uno, you just click on the Arduino Uno and drag it and hold it and drag it to the area where you want to place the Arduino board. Here I am placing my Arduino board. This is, you can see that this Arduino board is similar to the Arduino board which you are going to purchase in the market. The pins, everything will be same for this Arduino board. And after that, we need an LED because we are going to interface an LED with the Arduino board. So again, go here, search for LED. Here you have an LED. So select this LED, hold it, and bring it onto your workspace. And you can select here the which color you want for your LED. I am selecting my blue color. Okay. And after selecting the blue color, now I have an Arduino, I have an LED, and now I want to have an breadboard, right? So just search for the breadboard. You have a breadboard here. I am taking a small breadboard. So hold the breadboard and place it here in the workspace where you are working. This is the breadboard, right? Whenever you keep the breadboard on your workspace, the LED will automatically get connected in your breadboard, like you can see here, right? First of all, before using a breadboard, you need to know how the connections will be there in the breadboard, right? You can see here there are some vertical lines and there are some horizontal lines in the breadboard, right? So these particular horizontal lines, the top two horizontal lines and the bottom two horizontal lines, all these are used mainly for the power supply, and it is not compulsory that you have to use that particular lines for power supply. You can also use these lines for connecting the devices, but in most of the applications, the top two horizontal rows and the bottom two horizontal rows are used for giving the power supply, right? And for this connection, like if you had placed an positive terminal here, then the whole line from starting from here to up to that end, the whole row, for example, I am connecting here my one of the terminal, the complete row will get short circuited. That means if you use one pin here, if you connect another pin, another some other component here, these two components will get interconnected in the background, because the whole line will be short circuited at the background. Similarly, this line also. Similarly, this one, and similarly this one. So whatever the horizontal lines you are having in the breadboard, all these horizontal lines are short circuited in the background, right? And coming on to the vertical lines, you have it divided in between these vertical lines, right? In above the divider there are some vertical lines, and below the divider there are some vertical lines, right? For example, you have if you connect one LED in one of the point here, I am connecting one of the LED here, right? And I am connecting another LED, I am connecting another terminal here below that. But that means if you use one pin in that line, and if you the whole line will get short circuited. That means if you for example, I am connecting my uh, LED's positive terminal to the third line, first hole of the third line, and if I connect another LED's positive to the same tower line, that both the LEDs are getting short circuited at the background, right? That means I am just making you people to understand that in a breadboard, if all those horizontal lines are interconnected at the background, right? If as you people know that like let us see, take an LED. This is one of my LED. So whenever you purchase an LED, the LED will majorly have two pins, right? One is anode and another is cathode. Anode means the positive terminal and the cathode means the negative terminal, right? So how can you identify which one is the anode and which one is the cathode, right? So in majorly in the LED, the longest pin. That means whenever you purchase an LED, one of the pin will be length of the pin will be long, and another length will be short. The pin that is longer in length is the anode, and the pin that is shorter in length will be the anode or cathode, right? Or if there is a pin, that pin has some bend on it, then it will definitely represent your anode pin, and another one will be your cathode pin, right? So as you can see, I had placed my cathode in one vertical column and I had placed my anode in other vertical column. That means here these two are not getting short circuited. Like if you had connected your anode in the like I had connected my anode in the second row, and I had connected cathode in the same second row, then your LED will get short circuited. As I had said you that all these vertical lines will be short circuited at the background, right? That means if you connect one pin at the fifth terminal, fifth line, and you are connecting another pin at the fifth line, that means those two pins, though you had placed the two pins in two different holes, but at the background the two pins are getting short circuited, right? That means all these vertical lines are short circuited at their background, right? That means the major application of this breadboard is to connect various circuits easily just by placing the wires in between them, right? So just understand that point, that if I use a pin in seventh column, and if I connect another um, pin at any of the hole in the seventh column, just then those two pins are getting short circuited at the background, right? But here I am using a LED, and in LED, if anode and cathode get short circuited, then your LED will not is not going to work, right? So I am placing the anode I am placing the anode in 19th row, and I am placing the cathode in the 18th column, right? So these two columns are separate because so there is no short circuit because I am separating placing the two terminals in two different columns, right? So my LED is not getting short circuited. And then now let us connect the LED Arduino to the LED. Okay, so like uh, in the Arduino board, all these, as I already said, that LED requires 5 volts or 0 volts. Whenever we give a 5 volts supply to the LED will get on, and whenever I give a 0 volts to the LED will get off, right? So as for the LED, if we want to give a positive supply to the anode, and we have to give a negative supply to the cathode, right? That means the anode should be connected to 5 volts pin, and the cathode should be connected to the ground, right? But here I am going to make the LED on and off, right? So I had to connect the anode pin of the LED to any of these 13 pins, right? To any of these 13 pins. Let us think that I am going to use connect my LED to the 13th pin, right? From the 13th pin, I am taking a connector, and I am going to connect this 13th pin of the Arduino to the anode of the LED, right? You can see that I had connected my 13th pin of my Arduino to anode terminal of the LED. You can see that I had LED placed LEDs one pin here, and I had placed the 13 pin wire below that. Those two pins are getting short circuited background, right? If you want, I can make it zoom for you. You can see here clearly. I am placing the wire and the LED anode both on the same row. So, but though they are placed in different holes, they are interconnected at background, right? And then this will give the positive supply to the. We are connected the 13 pin to the LED anode. This is going to give the positive supply to the LED. Now we are going to connect the ground pin, right? So take any of the ground from the Arduino and connect it to the row where you have placed the cathode terminal of the LED. This is the complete wiring of your Arduino code for making LED on and off. That means we had connected the anode of the LED to the 13 pin of Arduino and cathode of the LED to ground terminal of anode, ground terminal of the Arduino, right? Like this. So now we have to view the supply on this 13th pin. For let us consider that I am going to make LED on for 1 second, and I am going to make LED off for 1 second, and again on for 1 second, off for 1 second, on for 1 second, off for 1 second, right? So as I am connecting my LED to 13th pin and my ground to the ground, that means I am connecting the LED to the 13th pin, right? So I have to make the 13th pin high for 1 second, and I have to make the LED 0 for the 1 second, right? Whenever I make the 13 pin high for 1 second, LED will get on, and whenever I will make the LED low for whenever I will make my 13 pin low for 1 second, my LED is going to off, right? So let us make coding for that. So you can easily get the blink code from go to file menu, and in the examples go to basics, and in the basics just go for blink. So this is your blink LEDs coding, right? So here you can see that as I am connecting my LED to the 13 pin, so in the voice setup I am going to write the pin number on which I am going to connect my LED, right? As I had connected my LED to the 13 pin of the Arduino, so as I already said you that whatever we will write in the voice setup loop, it will run for one time, and whatever we will write in while loop, it will run continuously online until you will shut down your Arduino board, right? So in the voice setup, I have to make setup. That means I have to make the Arduino know that what it has to do initially before running the program, right? So initially my Arduino has to know that on which pin I had connected my LED, right? So according to the diagram which I have shown you, I have connected the LED to the 13th pin of Arduino, right? So in the coding, we are going to write pin mode. Whenever you write the pin mode, that means you are going to define the Arduino that which pin you are going to use, and are you going to use the pin as an input or as an output, right? So here I am going to make the LED on and off, right? That means I am going to give a signal to the LED from Arduino. That means Arduino is going to give signal to an LED, right? So the 13 pin of the Arduino will act as an output because it is giving the signal to the, that means the signal is going out from the Arduino to an LED, right? So the signal is going out from the Arduino. So we have to define the pin as the output, right? So we are using the command pin mode here, pin mode 13, and after opening the bracket we have to write the pin number, which pin we are going to use. We are going to use the 13 pin. That is why I have written here 13 pin, and after 13 pin I have to write that what I am going to use this pin, either as input or as output. I am using it as an output, so I have written here output, and then I am going to close my code, and then this is what I am going to write only in the voice setup. Remember one thing, I am not mentioning the baud rate here, because if you didn't write the baud rate here, then the Arduino IDE will by default think that you are running at a default baud rate of 9600, right? So in the voice setup, I am just defining the pin mode, right? I am just defining the Arduino that 13 pin has to be used as an output pin. So here the code different that pin mode 13 as output. That means the Arduino will go to understand that I have to use the 13 pin and I have to use the 13 pin as an output pin. Then let us come into the while loop. The Whenever you switch on your Arduino, the Arduino first of all go into the voice setup, and it will set the 13 pin as an output pin, and then it will come into an while loop. And here we have to write the main coding for making LED on and off, right? So here, as I am using the 13 pin of the Arduino, as we know that the 13 pin of the Arduino is a digital pin, right? So we are going to give an output to an LED, right? So we are going to write something to an LED. So we are writing here digital, because we are using a digital pin, and after that we are using write. We are using write because we are giving a signal to the LED. We are not taking signal. If you are going to take signal from LED, then you have to use read here. But as I am giving the signal to the LED, we are have to write. So I am using the 13 pin, and then I am using the 13 pin to give a signal to the LED. So I am reading digital write. That means the digital pin is going to write the signal to LED. And then in the bracket we have to write the pin number, right? Because we are making 13 pin high, right? So here I am going to write 13. That means write the 13 pin comma high. That means 13 pin is going to make high. And then I want the 13 pin to be high for 1 second, right? In Arduino, whenever you write in the delay, you have to write the delay in milliseconds, right? That means 1000 milliseconds will be equal to 1 second. So I am writing delay 1000. That means my Arduino is going to make the high. Initially, it is going to make the 13 pin high. That means my LED going to turn on, and then it will wait for 1 second. That means 1000 milliseconds means it will wait for 1 second, and after waiting for 1 second, it will go to the next line. In the next line, I am writing the same command like digital write. That means I am going to write the digital pin. This time I am going to write the digital pin as low, because now I want to turn off my LED. Whenever I want to turn off my LED, I have to write digital low. So here I am writing 13 comma low. So whenever the the code come here, it will understand that I have to make the digital pin low. So it will make low, and then my LED get off. And after my LED getting off, it will have to wait for again 1 second. So I have written again the delay function with 1000 milliseconds. That means 1 second. And again the Arduino will go here, and it will again go here. It will as here we are getting 13 pin high. It will again make LED on, and then it will come to the next line. And in the next line we have digital delay 1000. It will wait for 1 second, and then it will go to the next line. In the next line we are going to write 32 pin low. That means your LED going to off, and then it will wait for another 1000 milliseconds. That means another 1 second. Again your LED is getting off, and then again right. That means in this way my LED is going to blink for every 1 second at an interval of 1 second. In this way continuously my LED will get on off, and it will blink in the same manner how we want, right? So I have written the complete code here, and then I am going to click on the verify button. After here I am going to click on verify. Whenever I click on the verify, the Arduino will prompt you to save your code. So let us save it with a unique name like LED, and after saving it, the Arduino will check that is there any syntax error in this code. As you can see here that here it has written that done compiling. That means there is no any error in the code, and then I can go to I can carry on for uploading the code into the Arduino board. Then I will click on the upload button, and my Arduino code is getting uploaded into the board. Here you can clearly see that it has given done uploading. Now let us see, is my LED blinking or not. You can see on the display that my LED is blinking for 1 millisecond delay. Like for 1 second it is getting high and then low, high and then low, high and then low. In this way you can make an LED blink at any regular interval of time. Let us try something. Let us uh, decrease the time. Like I am going to make my delay 200 milliseconds, right? 200 milliseconds. That means I am going to make my LED blink for 2 milliseconds high and then maybe 0.2 seconds high. That means this time the flickering will be fast. Let us see what will happen. Coding has been uploaded successfully. You can see now your LED is blinking at much faster rate. In this way, you can make your LED blink by using an Arduino board. This is just basic how to make your LED blink. So So this is how you can connect an LED to your Arduino board. As here I have shown you an hardware. I am having an Arduino board, so I had connected an LED and made that LED to blink. But if you let us think that you don't have an Arduino board and you don't have an LED, then how can you do it? So it's a very simple way. Uh, ThinkerCAD software, and in the ThinkerCAD software, as I had where I had given shown you the connection, connect in the same manner as I had explained you previously, and then here at the rightmost top side you have a option known as code. Click on the code, and after clicking on the code, here you will get the blocks. But we are not using any blocks because as we are writing an code, it is a text. So click on this and click on text, and it will ask, are you sure you want to use the text? Click on continue, and after that this is the code that we are using, the same code that we are using here. We are defining the pin mode as 13 pin output high, and then 13 high, and then delay, and then 13 low, and then delay, right? We are writing the same code here. Like here I have written pin mode 13 output, and then digital pin high, and then delay, and then low, and here, right? So write your code here, same voice setup, whatever the code you have written in the Arduino IDE software, the same code you have to write here, and then click on the start simulate button. You can see here the LED is blinking in the same manner as it is blinking in my previous hardware, right? Same in the same manner. Let us reduce the time here. As I am going to reduce it to like stop. Click on the stop simulation and then reduce the time to 200 milliseconds, right? Again click on the start simulate option. You can see here your LED is blinking for at a much faster rate as it is blinking in my Arduino board. You can see the same function that is happening in here in the Arduino board. You can see the same function, like here my LED is blinking at the fast rate. This is my hardware where I dumped my code, and this is my virtual software where I'm using the same Arduino code, right? So in this way you can make the Arduino code run in your hardware, and if you don't have a hardware you can use this thinkcad.com platform for making the same operation that you are going to make in the Arduino board here, right? So this is how we can interface an LED with the Arduino board. This is a very basic video, as it is a long video because I had explained you in a clear manner how the Arduino and how the code is getting run, right? Thank you for watching video.